All right, so the first question is about the type 1 or type 2 error. Suppose that he eventually decides not to buy the wax, but it would really lower his average time to below 55 seconds. What type of error would he have made? So the first thing that I'm going to do is, in part B, is write the hypothesis, or the hypotheses. So our null hypothesis is that our mean is 55 seconds. Make sure that your null hypothesis is always an equal sign. It's not going to be a less than or greater than. It's always going to be an equal sign. Your alternative hypothesis, since he's looking to see if this made the average less than 55 seconds, the alternative is that mu would be less than 55 seconds. So, suppose that he eventually decides not to buy the wax, but it really would lower his average time. So in that case, if it really would lower his average time, is the null hypothesis true or is the alternative hypothesis true? The alternative. So we should be rejecting the null hypothesis, and he is failing to reject it. So if the null hypothesis is false, and he fails to reject it, that is a type 2 error. So the null is false. But he fails to reject. So we have our hypotheses written from, for part B. We're going to run through the entire hypothesis test here. As I mentioned before, this is not a random sample, but we can assume reasonably representative of his races. That also means we're probably not going to generalize this information beyond this skier, because we're not running this test with anybody else. We're not doing a random sample of skiers or anything like that. The 10% condition is not totally necessary. It's not going to hurt you if you ran it, or if you checked it. What you do need to check, particularly because our sample size is so small, is the nearly normal condition. So if you have your data in list 1, you have all the race times, and you do a stat plot. Nope. Stat plot, make sure you're on the histogram, down to L1, and graph this. So I'm going to zoom 9 to show you what it looks like. I usually like to have at least 4 bars. It's a little bit tougher when you've got 5 bars. It's usually a little tougher when you've only got 8 pieces of information. Why can I not think of the word there? Anyway, the nearly normal, there is a slight outlier there, but nothing like so far out that I'd be really concerned about that, so I would call that roughly unimodal and symmetric. And because we had to create our own histogram, I'm going to sketch that as well. So, based on this, we can proceed with the one sample t-test. And this would be with 7 degrees of freedom, because that's 1 fewer than our sample size. Not totally necessary to put that there, by the way. The information that I'm going to use I got from the calculator, and I'll show you the test way of doing this as well. Whoops, not what I meant to do. So I'm going to calculate my stats for L1. So I have a mean of 53.1, a standard deviation. When you use these, by the way, you're going to use the SX. So 7.0285. The N was 8, and this doesn't come up there, but our degrees of freedom is 7. So that's the information that I am using. Those are my observed statistics that I'm using to compare to what should be happening. So the T calculation, one thing, and most of you guys did pretty well with this with the Unit 5 test, is make sure you mention what test you're running. Not just that you're going to run a test or that your conditions have been met, but conditions have been met, I'm going to run a whatever type of test, in this case the one sample T test. So my T statistic is calculated by my observed mean minus my hypothesized mean divided by standard error of my observed mean. That calculation, that standard error calculation is, well, it has it as sigma on your formula sheet, but it's the observed mean over the square root of n. Not the mean, sorry. S over square root of n, your observed standard deviation. My apologies. So our observed mean, 53.1, minus our hypothesized mean of 55. And then our observed standard deviation was 7.0285 divided by the square root of 8. So what I'm going to do is pop this in the calculator in one shot. You can show more work than that, but if you can put it all in one shot, then you don't have to round things off earlier on. So 53.1 minus 55, close your parentheses, divided by 7.0285 divided by the square root of 8. So we've got a T statistic of negative 0.7646. Any questions on that? So, with that T statistic, we need to find a p-value, and that is the probability that T would be less than, and I'm going with less than because that's my alternative hypothesis. T would be less than negative 0.7646. The way I'm actually going to find that in the calculator is, and you don't have to write this part down, I'm just writing it down so you guys know what steps you're taking to get there, is the TCDF, negative 99, negative 0.7646, and then your degrees of freedom. That's the part you have to add with the T model that you don't have to do with the normal model. So second bars, TCDF, negative 99, negative 0.7646, comma 7. Take the sugar. And that gives us a p-value of 0.2347. That is a pretty high p-value. So when I have a high p-value, I'm going to fail to reject the null. So based on the high p-value, I'm going to fail to reject the null. And another thing that I saw on your test was a lot of people saying whether we had evidence that the null was true, and that's not what we're looking for. So always link your p-value or your decision to your p-value. Your decision is to either reject the null or fail to reject the null. If you have a low p-value, you reject the null. If you have a high p-value, you fail to reject the null. You are failing to reject or rejecting the null in favor of or looking for evidence of alternative hypothesis. So when you say there is or is not evidence, you're talking about the alternative hypothesis, not the null hypothesis. So what I saw a lot of on the test, on the Unit 5 test, was people saying there is evidence that, like in this case, there's evidence that the mean is only 55. And that's not what you're doing. You never, ever, ever accept the null or even come close to sounding like you're accepting the null. you are saying, in this case, I failed to reject the null, and I'm saying that because I do not have enough evidence that the true mean is less than 55 seconds. So it's always, the evidence you're looking for is always either in favor of the alternative or not having enough evidence of the alternative. So in this case, there is not evidence that the true mean time would be less than the 55 seconds. And because it asks what our recommendation would be, we would not recommend that he buys that wax. So, real briefly, I'm also going to show you the test part of that on the calculator. So if you go to Stat and over to Test, t-test, we have the data in this particular case already in list 1. Our hypothesized mean is 55. Our list is L1, at least in my calculator. Our alternative hypothesis is that the mu is less than the null hypothesis, so less than 55, and then I'm going to calculate. That's going to give me my t and my p-value, as well as the rest of the information that I have in there. One of the really important things with this is if you choose to do your test this way, and that's what you choose to show, you absolutely need to put that it's from the calculator, from technology, or something that tells me where those numbers are coming from. If you just have numbers there, that is not acceptable. So make sure that if you put it in the test portion, if you're doing it that way, that you're writing down that it was from the calculator. In terms of the AP exam, it's my impression that with one sample Z and one sample T tests, they want to see those calculations because they're not horrific calculations to do. That's my impression. They're still very unclear on it. And so for me, what it would come down to is the timing. If you are low on time, then I would put it in the test part of the calculator and write out what the calculator spits out. If you have more time, I would write the calculations. And I don't know overall what that expectation is on the AP exam. My expectations for my exams is that if you have, if it's a one sample T test or one sample Z test, you should be writing those calculations down. Two sample, I would say that's not quite as necessary. All right, so that is the one sample T test.